Okay, just recapping what we're going over today. So I wanted to go over question 2 and 8 from assignment 4. Question 2 is a positive equation answer, so I've ticked the positive quadrants for cos, which is the first and the fourth quadrant. I've just written A over at the side because I call that my acute angle, because that's not always an answer. It will be in this case because we've ticked the first quadrant, but it's not always. So then to get the 30 degrees, you just do shift cos root 3 over 2, or root 3 divided by 2. If you couldn't get it to work on the calculator, just remember to move your cursor. As soon as you type in the root 3, you need to move your right hand cursor along so that the division sign isn't underneath the square root. And hopefully that works out. Okay, so 30 degrees is your acute angle. The fourth quadrant is 360 minus 30 degrees. So 330 degrees. And that's your two answers for that one. Here's question 8. Some of you were getting 7, 8 and 9 wrong because there were negatives. So I've just actually left this one as negative 2 over 4. You don't need to simplify it down to negative a half because you're using a calculator. But when you come to take the acute angle, don't put a negative in here. Keep that positive, because that should be an acute angle. You know that acute means between 0 and 90 degrees. So if you don't get an acute angle, you've done something wrong. Okay, this is cosine and it's negative because it's negative 2 over 4. If cosine was positive, you would tick first and fourth quadrant. So that's why I've ticked the opposite too. And remember, it's 180 degrees here. So the second quadrant is 180 minus your acute angle, and the third quadrant is 180 plus your acute angle. So that's where I'm getting the 120 degrees and the 240 degrees from. Okay, there were some questions like this in the book where it was sine squared or cos squared or tan squared x. Now, all that means is tan x all squared equals 3. So to find tan x, you need to take the square root of the 3, but you also need to write that it could be the positive or the negative of that root 3. Because if you were to square negative root 3, you would get back to positive 3. So it's a positive or negative when you're taking a square root. So tick all 4 quadrants because it could be positive or it could be negative. To get the acute angle, it's just shift tan of root 3, which gives us 60 degrees, and then that's all 4 quadrant answers. So I've subtracted from 180, added to 180, and subtracted from 360 to get our 4 answers. Okay, moving on to trig identities. These are the only 2 trig identities you need to learn. They're the only ones that come up at National 5 level. So you need to know that sine squared x plus cos squared x equals 1. You also need to know that sine x divided by cos x equals tan x. Now I've used x. It doesn't need to be x. It can be any letter you like as long as it's consistent. So if it was sine squared a, it would have to be cos squared a as well, and so on. Now for this one, you need to be able to rearrange it because sometimes you're going to replace sine squared x, and sometimes you're going to replace cos squared x. So hopefully you'll know where they come from. For sine squared x, you're just going to subtract the cos squared x from the 1 on the other side. And to find cos squared x, you're just going to take the sine squared x away. So if you can learn that bubble and that bubble, that's all you need to know for trig identities, and then you just need to be able to manipulate them yourselves. Okay, so looking at an example with the tan one. So the question is, prove that tan p cos p equals sine p. Tan p cos p just means tan p times cos p or multiplied by cos p. So start off with the left hand side, copy the left hand side out, replace tan p with our trig identity, and you've just learned that tan is sine over cos. So the sine over cos went in, and then this cos just stays at the side. If it's being multiplied, it would join in with the numerator. So then we can cancel through, and you're just left with sine p, which is the right hand side, and we're all good. Okay, this is another one I want to go over. The left hand side is the double brackets, the right hand side is this little bit here. I just couldn't fit it in way over here, so I've just tucked it underneath. So we'll write out the left hand side equals a double bracket, and then you just multiply that out using the FOIL method. So sine times sine is sine squared, cos times cos is cos squared, but that's your last term, so put that here. The insides are minus sine x cos x, and your outsides are also minus sine x cos x. So I've just done the FOIL method and got our 4 terms there. And then on my next line, I've written the sine squared x and the cos squared x together. The only reason I've put it in a bracket is to remind me that I'm going to replace that with the number 1 from the trig identity that we've learnt just a few minutes ago. So, and there's 2 of these, so that's where the minus 2 sine x cos x comes from. And then if we make that a 1, we'll end up with the right hand side. And that's how we do that one. In the textbook, there's also questions like this. We are told sine, cos or tan is a fraction and you're asked to find the other trig values. So remember SOHCAHTOA from trig, from basic trig. Sine x equals 4/5. Just draw yourself a right angle triangle, put your x in one of the angle corners. And for sine, sine is opposite over hypotenuse. So that's our opposite, that's our hypotenuse. So the 4 has to go in the opposite position from the x. So if I had decided to draw my x up there, that's fine, but then my 4 would have to be written down here. Okay? And the 5 is in the hypotenuse position. Now, how did I get the 3? I got the 3 from just Pythagoras. So 5 squared take away 4 squared is 9, and the square root of 9 is 3. So now it's really easy to go find cos and tan. Cos is ka, so adjacent over hypotenuse. So my adjacent is 3, my hypotenuse is 5, and that's where the 3/5 comes from. Tan is toa, so opposite over adjacent, so 4/3. Because 4 is opposite and 3 is adjacent to the value x that's on the diagram. Here's a similar one, but with cos this time. So cos y equals 12/13. And we'll have to find sine y and tan y. So I've just drawn up a right angle triangle again. Cos is ka, so adjacent over hypotenuse, so adjacent is 12, hypotenuse is 13. To find 5, just do 13 squared, take away 12 squared and square root, which is 25, and then the square root of 25 would give us the 5. Okay, to find sine, it's just so opposite over hypotenuse, opposite the y is 5, and the hypotenuse is 13, so 5/13. The tan is toa, so opposite over adjacent, so 5/12. So if you get something like that, just draw yourself a right angle triangle, put in what you know, use Pythagoras to find the third side, and then just remember your SOHCAHTOA. Okay, so this is question 2 and 5 from the assignment 5, just to go over them in case you're struggling with them. So start with the left hand side. You've got sine x divided by tan x. They've written it as a fraction, but I'm writing it sideways because I'm going to find it easier once I start doing my substitution. So instead of tan x, because of my trig identity, I know that I can replace tan x with sine over cos. Put a multiplication sign in, flip the second fraction upside down. You learned how to do that in second year with fractions. Sine x, you can make that over 1, multiply your tops, multiply your bottoms, and then we can cancel through. And that's how we end up with cos x, which is our right hand side. Okay, here's question 5. So the left hand side I've just copied back down, but from this trig identity, I can see that sine squared a is 1 minus cos squared a, so I can replace my 1 minus cos squared a with sine squared a. And now I've just got sine over cos all squared, and sine over cos is tan, so that's just the same as tan all squared, and we can write it like that. These are difficult when you're just starting out on them, so please don't stress if you're finding this pretty difficult. Just lots of practice. And remember, we've got all the past paper questions per topic, so you can go into trig identities there and look through all the solutions for them, and hopefully you'll just gradually keep getting better at them. But this is the hardest thing apart from quadratics that comes up, and it's only worth normally about 2 marks at the end of the paper, so please don't worry about it.